Welcome everyone. In this session, we will see software testing. To perform software testing, we have two broad methods, categories, white box method and black box method. And both methods have a different strategies. So let us start with the white box testing. The goal of white box testing is to test the internal structure of the code, and hence the name of white box testing, we can say it's a glass box testing. So our goal is to ensure that all statements and conditions have been executed at least once. Now why to cover? So it gives a logical errors and incorrect assumptions are inversely proportional to the path's execution probability. So we have to test the path. We often believe that path is not likely to be executed. It may happen that some of the paths are not at all executed, and in fact, reality is often counterintuitive. So at that time, when runtime, when user executes and it executes that path that we haven't checked. So for that, white box testing is required. Typographical errors are random. It's likely that untested paths will contain some. So the first strategy in white box testing is a basic path testing. So first we compute the cyclomatic complexity. Cyclomatic complexity is a measure to identify the complexity of the system or a code. Now to identify the cyclomatic complexity, we have the first way is to identify the decision statement or prediction statement from the code plus 1. Another way to identify the cyclomatic complexity is the number of enclosed area, means a closed region plus 1. So here is a graph in which we have say 1, 2 and 3 condition statement, decision statement plus 1. So cyclomatic complexity of whatever code is given in this chart is 4. Number of enclosed area, you can see 1, 2 and this 3. So 3 plus 1, 4. So this is how we can find the cyclomatic complexity. Number of decision statement means condition plus 1 and number of enclosed area means region plus 1. Cyclomatic complexity means a number of industry studies have indicated that the higher the cyclomatic complexity, the higher the probability of error. Okay. So number of decision statement or condition statement should be less if you want to make your system less complex. So basic path testing. To identify the basic path, first you have to identify the cyclomatic complexity of the code. Now to identify the cyclomatic complexity, we have to identify how many decision statements are there in your code. Now if you have a compound decision statement, right, like if you write any condition using AND, say A is greater than B, AND operator, condition operator, and then B is greater than C, here you have to count as the 2 because 2 conditions we are checking, 2 decisions we have to take. So number of decision statement plus 1. So for this particular chart, we have 4 cyclomatic complexity. What it means, we have 4 distinct paths for this graph. Path 1 is 1, 2, 3, 6, 7, 8. Path 2 is 1, 2, 3, 5, 7, 8. Path 3 is 1, 2, 4, 7, 8. Path 4 is 1, 2, 4, 7. Then again we reaching to this, that is 2, right? Then 4, likewise. So here we have 4 distinct paths. And for this path, finally we derive test cases to execute or exercise this path. You don't need a flowchart, but the picture will help when you trace program paths. Count each simple logical test, compound test counts as a 2 or more. Basic path testing should be applied to critical modules. Testing is the process of exercising a program with the specific intent of finding error prior to delivery to the end user. Now let us first brush up the testing objective. What is the major purpose to perform the testing? So testing is a process of executing a program with the intent of finding an error. And a successful test is one that uncovers an as yet undiscovered error. Right? So testing principles are there. All tests should be traceable to customer requirement. As we have seen, the objective of software testing is to uncover errors. It follows that the most severe defects from the customer's point of view are those that cause the program to fail to meet its requirement. Because a successful software is the software that meets all the user's requirement. So all tests should be traceable to the customer requirement. Second testing principle is tests should be planned long before testing begins. It is not the case when we are starting the process of testing the software, at that time we plan the test. It should be planned before we start the actual testing. The basic principle applies to software testing. Stated simply, the Pareto principle, the basic principle implies that 80% of all errors uncovered during the testing will likely to be traceable to 20% of all programs components. It means that the errors are not randomly occur in the entire system. We have a particular or a targeted code that has the maximum amount of error reside in. The problem, of course, is to isolate these suspected components and to thoroughly test them. Then testing should begin in the small and progress towards testing in the large. It means we have to start testing with a small individual component. That is what the unit testing. And then we focus shifts in the attempt to find errors in the integrated clusters of components, and that ultimately leads to the entire system testing. So we have to start or we have to begin in a small portion of the code, and then we need to progress towards testing the entire system. Exhaustive testing is not possible. We have already discussed in a previous session that why exhaustive testing is not possible, because it takes years to test the entire system. So we have to focus on a selected path to test. To be most effective, testing should be conducted by an independent third party. Okay, we have already seen in the previous session that developers are also the part of a tester. They do the unit testing, but to test the quality, to test the conformance of the requirement, to test the performance of the software, we require a third party, that is a specific tester or quality analyst, we can say. So we require them to effectively test the software. Now some of the keywords are very important when we work with the testing, and the first keyword is operability. It means the better it works, the more efficiently it can be tested. If your system is error-free, then you can test it in well manner. The system has few bugs. Bugs add analysis and reporting overhead to the test process. No bugs block the execution of the test, and the product evolves in a functional stages that allows simultaneous development and testing. Second important keyword is observability. So what you see is what you test. Distinct output is generated for each input. We have an input. When we write the test cases, we have to provide what is the input for the module and what are possible output when we test that particular module. So distinct output is generated for each input. System states and variables are visible. Then past system states and variables are visible. All factors affecting the output are visible. That should be traceable. Then only we can identify the proper error. Incorrect output is easily identified. Internal errors are automatically detected through self-testing mechanism. Internal errors are automatically reported and source code is accessible. Another term is controllability. The better we can control the software, the more the testing can be automated and optimized. Nowadays, industry moving to automated testing. So all possible output can be generated through some combination of input. All code is executable through some combination of input. Software and hardware states and variables can be controlled directly by the test engineer. Input and output formats are consistent and structured. Test can be conveniently specified, automated, and reproduced. Decomposability. By controlling the scope of testing, we can more quickly isolate problems and perform smarter retesting. Right? As we have seen that the 20% of the program that contains the 80% of the error. So we try to decompose that portion. We test it effectively and try to identify as many as error. So the software system is built from independent modules. Software modules can be tested independently. The another keyword is stability. The fewer the changes, the fewer the disruption to the testing. Changes to the software are infrequent because if we have changes, that code may affect the previously successfully executed code and they may introduce a new bugs. Changes to the software are controlled. Changes to the software do not invalidate existing test. It should not affect the existing state of the code. The software recovers well from the failure. Another keyword is understandability. The more information we have, the smarter we will test. So the design is well understood. Dependency between internal, external, and shared components are well understood. Changes to the design are communicated. Technical document is instantly accessible. Technical documentation is well organized. Technical documentation is specific and detailed. So it will help the tester to understand the system better because they haven't implemented the software. They are a third party. So to better understanding, they require this kind of technical documents well organized and technical document is accurate. So we have seen the characteristics of testable software. It should be operable, observable, controllable, decomposable, simple, stable, and understandable. Test characteristics. A good test has a high probability of finding error. The tester must understand the software and how it might fail. The third party must know how we can break the system. A good test is not redundant. So testing time is limited. So it should not happen that when we have a different test cases that produces the same error. Different test cases must produce a distinct error. A good test should be best of breed. So tests that have the highest likelihood of uncovering a whole class of errors should be used. A good test should be neither too simple nor too complex. Now, two unique testing techniques. The first is black box testing and second is a white box testing. Black box testing, knowing the specific function that a product has been designed to perform, test to see if that function is fully operational and error-free. So here we will check the behavior of the function. Whatever is the behavior of the function or it is mentioned by the customer in a SRS, the function executes the same way or not. So it is input-output specific. Includes tests that are conducted at the software interface and not concerned with the internal logic structure of the software. So that is a black box testing. We do not care of internal structure. What we care is behavior of the function. Whatever is intended outcome, whether we are getting for this input or not, that we are checking in a black box testing. On the other hand, white box testing is knowing the internal working of the product. We test that all internal operations are performed according to specification and all internal components have been exercised or not. It involves tests that concentrate on close examination of procedural details. So internal structure of the code we are evaluating, logical paths we evaluate, and test cases exercise specific set of conditions and loops. So in this session we'll end over here. In next session we will start in a detailed white box testing. Thank you.